Okay, so we're gonna continue with um, you know um, working with the rational expressions. But today the focus for today's class will be kind of like a mixed question, okay, where you have addition and multiplication. Um, so over here, I guess the question becomes how to proceed, right? What should you do first, and then what should you do next? So it kind of like combines what we did last week with what we did yesterday. Okay, so let's proceed. Um, so okay, so let's start off with something simple, right? So we just have three fractions over here. Two of them are being multiplied, and then one of them is being added, right? So the question becomes, what should you do first? Okay, so again, this here, you're not solving for anything. You actually have to simplify this into maybe one fraction, right? You're not solving for anything. You don't have to do algebra. You don't have to do the inverse. So because you're not solving for anything, you're just simplifying. In this case, you'll have to use BEDMAS, but in forward direction, okay, which is something that we rarely do at this level. Um, right? Again, because only because we're simplifying, we're not solving. Okay, so eventually we'll have to solve. So that's when we'll have to do BEDMAS in reverse direction. Okay, so what does this mean? So in forward direction means that my priority will be division and multiplication, right? I have to do division and multiplication first, followed by addition and subtraction. Okay, um, so in this case, right, in this question, I'm gonna have to multiply first and then I will have to add. Okay, so multiplying isn't difficult, right? Because you just have to multiply your numerator by your numerator and denominator by a denominator, right? So the 1 over 4 stays the same, plus, and now these two fractions will get multiplied. So 1 times 2 is just 2, and then 2 times 3 is 6. Okay, so now this is my question. Okay, so again, so now this looks much better. This looks like what we did in yesterday's class, right? Class 5. So how do you add two fractions, right? The the method that I showed you is you have to factor the denominator. Okay, so 4 is just 2 times 2 because 4 is not prime, and 6 is not prime either, so 6 is 2 times 3. And then you just have to compare your denominators, right? So this guy on the left, what is this guy missing that this guy has, right? So what is what am I missing over here in this denominator? And it turns out that I'm missing the number 3, right? So I'm going to have to multiply my denominator um, by 3. And then I have to multiply numerator by 3, right? And then now I have everything, right? The 2 is here, the 2, the 3, 3. So on the left-hand side, I have everything that the right-hand side has. Now, what does the right-hand side not have that the left-hand side does, okay? So I have the 2, I have the 3, I'm just missing a 2, okay? So I'm going to just have to um, multiply this by, if you want, you can put the 2 anywhere you want. So let's just put the 2 here. 2. Okay, so that's how you find the lowest common denominator, right? And in this case, it's 12. So the next step is once you have the same denominator, you have to multiply your numerators, right? So 3 times 1 is just 3. And the bottom, you have 2 times 2 times 3. And for this one, 2 times 2 is actually 4. Again, you'll have to multiply this out, okay? Because there's no way you can add these numbers as they currently stand. You'll have to multiply them out, and then you have to combine like terms. Okay, so you're gonna have to multiply first, and then simplify if it's possible. Okay, and this is still 2 times 2 times 3. Okay, I'm just putting it in increasing order. Okay, and now because I have the same denominator, right, I can just add my numerator. So my final answer will just be 7 over 2 times 2 times 3. And this is kind of like the final answer when it comes to rational expressions. You don't have to remultiply your denominator again, but with numbers, I guess you could do that, right? So my final answer will actually be 7 over 12. Okay, oops, 12. So now let's extend this idea to rational expressions. So let's move on. Okay, so here, this is kind of like, I guess, um, a mixed question, right? But in this case, you only have addition and subtraction. Okay, so when you have addition and subtraction, you have to do whatever comes first. Okay, and in English, we're reading from left to right. So because that's how we read, we do math in a similar fashion. Okay, so if addition comes before subtraction, then you're gonna have to add first. What do I mean by that? If you want, you can just add the brackets to tell you that this is my priority. In this case, you're gonna have to subtract first before you add. Okay, so basically that's what you're doing. The question is, the question I guess becomes to find the common denominator, right? So again, how do you find the common denominator? Because now you have three of them, so you're gonna have to compare all three of them to each other. So no worries. Let me just rewrite this. So 2 s over 5t squared plus 1 over, I'm just gonna break the 10 into 2 times 5t. Okay, minus, and then the numerator I don't really care about, so let's just leave that as 6 for now, and 15 will just be 3 times 5t cubed. Okay, so now let's compare the denominators to each other. So this guy has a 5. But now I'm gonna have to compare this to this denominator and that one as well. Okay, which might be a little tricky. So let's just do this one at a time. Okay, so let's compare it to this denominator. What am I missing? Turns out I'm missing a 2. Okay, so I'm gonna multiply this by 2 and I multiply this by 2. So now I have the 2, I have the 5, I also have the t. Okay, so that's good enough for me. Now let's compare it to this guy. What am I missing? I'm missing the 3, so let's multiply this by 3. So I'm gonna have to multiply this by 3. So this is okay. So now the 3 is here, the 5 is here, and I'm also missing a t, right? Because this is t cubed, this is just t squared. So I'm gonna have to multiply this by t, and then I'm gonna have to multiply this by t. So this one seems to be completed, okay? Now I'm gonna compare my second denominator to the first one, which is complete. Okay, so what is my second denominator missing? I am missing a 3, right? So I'm gonna multiply this by 3. So 2, 3, 5, and it has to be t cubed, so I'm missing a t squared, and then I'm missing a t squared, okay? Now what is this guy missing? T cubed is there, 5 is there. It's just missing a 2. So I'm going to have to multiply this by 2. I'm going to have to multiply this by 2, okay? And now we have the common denominator. So if it's really bothering you, right, let's just put everything together. So on top, I have 2 times 2 times 3. So 2 times 2 is 4, 4 times 3 is 12. So I have 12s. And at the bottom, I can just, put everything together. So 5, 3 times 2 is 6, 6 times 5 is 30. So the common denominator is actually 30t cubed. And then I have a plus sign. And then um, over here I have 3t squared on top. And obviously I'm going to have the same denominator, which is 30t cubed. So again, if you multiply this out, 5 times 2 is 10, 10 times 3 is 30. So it was, we purposely made it so it will give us 30t cubed. So this guy becomes 12. 6 times 2 is 12. And at the bottom, I'm going to have 30t cubed, okay? So, um, so I guess my next step is, now that I have the same denominator, right? I can just probably going to have to add another page, which is fine. So now I can just combine everything together, and hopefully I can find some like terms, but that doesn't seem like Yeah, that's unlikely. So anyway, so let's combine it. So 12s plus 3t squared, because there are no like terms, right? And then 12, and then at the bottom you have 30t cubed. You're essentially done, but there's one thing that you can do, right? So there's you cannot factor anything in your numerator except for if you look very closely, right? The number 12, the number 3, and number 12 is divisible by something, and that something is 3. Okay, so I can actually pull out a 3. So this will just become 3 and then brackets 4s, right? Because 3 times 4 gives me 12s. And then plus t squared and then minus 4 over 30t cubed. And then you can kind of like cross out the 3, because the 3 divides 3, you get 1. 3 divides 30, and then you get 10. Okay, so your final answer is just the 30 will disappear, the 3 will disappear. So at the bottom, you're going to have 10t cubed. On top, you will have 4s plus t squared minus 4. Okay, so this is how you would do a question like this. Um, if you want, try doing the second one on your own, pause the video. But, I'm going to proceed, and you can maybe compare your answers. So this one, again, let's just add an extra page for this. So I'm just gonna recopy the question down here. So I have 6xy. It's gonna remove this. 6xy. Actually, that was kind of helping me. So I'm just gonna keep it for now. Once I copy the question, then I'll remove it. Okay, so 6xy over a squared b minus 2x over ab squared y plus 1. Okay, now let me remove this. So again, let's compare this denominator to this one. What am I missing? I am missing a b, right? So I'm going to multiply this by b to get b squared, and then this will have to get multiplied by b. So now I have the b squared, but I'm also missing the y. So actually, you know what? Let me just use the color blue to show you that I had to add the b, right? Because now I have this b squared. A is good. Okay, I have a squared. This guy only has an a, so I'm actually doing really good with my a, so I don't have to worry about that. I was just missing an extra b, and it turns out I'm also missing a y. Okay, so let's put the y here. Now, what is this guy missing? This guy is missing the a, right? Because this one is a squared. And b squared, yeah, so if you multiply by a, you have to multiply by a on top and at the bottom. Now this guy, your denominator is 1, and this guy is missing everything, right? So you'll have to multiply this guy by a squared b squared y. So that means, this also has to be a squared b squared y. And again, a squared b squared y divided by a squared b squared y is just 1, right? So because I'm multiplying by 1, I can kind of like remove the 1, right? The coefficient 1 is redundant. And now you have your common denominator, so you can add everything up. So let's just clean this up, because on top I have 6, right? And let's just make it alphabetical. So b, and then x, y squared, right? I think it was 6xy, right? Yeah, so y squared. So I'm just combining the y's together. And then denominator, you have a squared b squared y. This one is just 2 if you want ax. Again, it's just nice to keep it in alphabetical order, because then it's kind of like easy to simplify. A squared b squared, you don't have to keep it in alphabetical order. It just helps your brain be organized. Okay. So now, because I have the same denominator, right, I can add everything up. And when I do that, I I'm going to have 6bxy squared, and then so minus 2ax, and then plus a squared b squared y over a squared b squared y. Okay, now the question becomes, can I actually factor my numerator? So I have a b over here, I don't have a b. X, no x, y, no y, y. Yeah, so this would be a final answer because you cannot factor anything in your numerator, okay? Um, so the 6 and 2 is divisible by 2, but the coefficient over here is 1, so you cannot even factor the 2, or else this one will have to become a half, okay? And you don't want any decimals or fractions, so I cannot factor any numbers, and I cannot factor any variable because none of the terms have the variables repeating, right? You have an a over here, you have an a over here, but this guy is missing an a, so that doesn't work. Same thing with b, right? This guy has a b, this guy has a b, but there's no b up here. Same thing with x, right? You have an x here, an x here, but no x up here. And similar, same thing for y, right? There's a y here, there's a y there, but no y here. So this would be your final answer because I cannot factor this, okay? So this, I guess, kind of like a review of what we did last class, except now you have like three fractions. But you know, the idea kind of like is the same, right? You just have to find the lowest common denominator and work your way from there. Okay, so now this would be a more challenging question. And this is the last question. Okay, so after that, I'm gonna have you assign you your homework. So I picked this question from the textbook. It's actually question 5A. So I'm gonna do 5A, and then I'm gonna ask you to do B, C, and D. Okay. So here you have multiplication and addition, right? So you're gonna have to multiply first, and then whatever the result is, you're gonna have to add afterwards. Okay. So let's you know, factor. Um, you, you have to start by factoring your denominator. Okay, don't factor your numerator. Okay, please don't factor your numerator because you're gonna have to combine like terms. If you factor your numerator, well, I mean, you could factor your numerator sometimes. Actually, you know what? I think it's better to factor your numerator because what if you can simplify this fraction over here right away? Okay, so yeah, so let's just factor everything. Just to not take any chances. So for this guy, we're gonna have to do product sum. So two numbers that multiplies to -3, and they have to add up to -2. So 1 times 3, right? And because this is negative, the bigger number has to be negative, right? So because this is negative, so 1 minus 3 is actually -2. So let's just rewrite this. So x minus 2, x plus 5, this will not change because, you know, I'm going to have to simplify whatever I have inside the brackets first. And this turns out to become x plus 1, and then you have x minus 3. And now let's factor the denominator. And once we factor the denominator, I guess the non-permissible values will be more apparent, right? So let's erase this and do the same thing with the denominator. So I'm looking for two numbers that multiply to -6, and they have to add up to -1. So probably 2 times 3. Now because this is negative, so the bigger number has to be negative. 2 minus 3 is -1. Okay, perfect. So this one simplifies to x plus 2 and then x minus 3, right? So as you can see, it was actually a good idea to factor the numerator because now I can simplify, right? Um, and so multiplied by, I'm just gonna use dot for multiplication. I'm not gonna cross things out just yet because I have to list my non-permissible values. So let me just wait on that. So here, you know, the x is repeating itself, right? So you can factor the x. So you're going to get x plus 2. And at the bottom, you're going to have to factor the x. So if you factor the x, then you're going to get x minus 4. Okay, x squared minus 4x. Yes, okay. And now is the time to list your non-permissible values, right? So let's do this one at a time. So this guy tells me that x cannot equals to minus 5, right? So cannot equals to minus 5, and it cannot equals to minus 2. It cannot equals to, from here, 0. From here it has to be 3, and from here it has to be 4. Okay, so these are your non-permissible values because they will make your denominator 0. Okay, and again, you can you can list them from left to right and then arrange them in order, or you could just look at the values and then pick and choose them kind of like I did, so that they happen to be in order um, from the get-go, right? So now let's make this look a little nicer. So x minus 3 will cancel, x plus 2 will cancel, the x's will cancel. So you're not left with much, right? So this essentially just becomes x minus 2, x plus 5. So these guys will just stay the stay the same for now. And over here, x plus 1 survives in your numerator, so you're gonna have x plus 1, and in your denominator, x minus 4 survives, right? And just to avoid any confusion, just put brackets, okay? Just put brackets so that um, you don't make any silly mistakes, okay? So I'm just gonna put the bracket over here. And now ask yourself, I compare your denominator on the left. What is it missing that the denominator on the right has? Okay. Now with the brackets, it becomes really easy that I'm missing um, x minus 4, right? So I'm missing x minus 4, so I'm gonna have to multiply this by x minus 4, and I'm gonna multiply the numerator by x minus 4. And this guy over here is missing x plus 5, so I'm gonna multiply it by x plus 5, and then I'll have to do the same thing to the numerator. Okay, now I have the same denominator, but for me to add my numerators, I will have to multiply my brackets, right, first, because there's no way I can combine my like terms without multiplying. Okay, so this will get a little messy over here. So let's multiply this out. Again, do it however you want. So basically, you just have to distribute. So make sure you're multiplying everything, right? So x, um, yeah, let's just stick with red. So x times x, I get x squared, and then x times minus 4, I get minus 4x. Okay, and then don't forget about this negative 2. So negative 2 will also have to multiply, right? So negative 2 minus x is negative 2x, and negative 2 times negative 4. Okay, this is negative 4. Okay, so negative 2 times negative 4 is positive 8. Okay, and then you can kind of, like, if you want, combine these two together, right? So let's just do this right away to get minus 6x. Okay, so this will just become minus 6x plus 8, um, minus 6x plus 8, and your denominator is still x plus 5, x minus 4. Now let's do the same thing up here, right? So I'm gonna do this fairly quickly now. Okay, so I'm just gonna do this. So x times x will give me x squared, and then you're gonna get 5x times 5 will give you 5x, right? And then 1 times x will just give you x. So this will become plus 6x, right? So x squared plus 5x plus x, which is 6x, and then 1 times 5 is just 5. And then you have the same denominator. Now, because you've multiplied everything out, you can combine your like terms together, okay? See, you can only combine your like terms together when you're adding, okay? And to add, you need to get rid of your brackets, kind of like what I did up here, okay? So, um, Now let's just highlight stuff. So the x squared will combine with x squared, right? Because it's plus, I don't have to put brackets, okay? I don't have to put brackets. If this was a minus, then I would, because then the minus would have to distribute, right? But the plus, because it's plus, is just like multiplying by plus one, right? So that doesn't change anything. So you don't really need the brackets because it's plus. Um, and I'm gonna combine this minus 6x by plus 6x, right? So that will disappear. And then maybe, I don't know, let's just use blue or something. This is actually pretty cool. Um, okay, so yeah. So when you combine this together, um, this will just equals to 2x squared, right? The yellows will give me 2. The x term will cancel, and then 8 plus 5 is 13, okay? And then at the bottom, I'm going to have the same denominator, x plus 5, x minus 4. And I cannot I cannot simplify this any further because 13 is a prime number and 2 is a prime number. So I cannot really factor the two. If this was 12, then I could have. So this is it. Okay, so um, this would be your final answer because you can't really factor your numerator, right? Two, there's no number that divides both 2 and 13. And this 13 does not have any x's, right? If this was 13x, then I could have at least factored the x, but there's nothing that I can do. So this would be my final answer. So I just want you to practice, right? Do these three questions. And if you have some free time on your hand, right, and you did not do your homework from yesterday, uh, make sure you're doing more practice. Okay, so if you know you were busy and yesterday you were not able to complete all the homework questions, go back to the homework from yesterday, and do the other questions that were remaining. Okay, so I really want you to practice, and I'm hoping this is kind of making sense. So if you're having a hard time, please come join me on Thursday during my office hours. Again, you don't have to show up on time. I think when do I start my office hours? I think they start at like 10:30. So some students show up at 10:30, and that's good. But if you join me midway or 10 minutes before my office hours are over, I can still help you, right? You don't have to punctually show up exactly at 10:30. Um, just show up whenever you can between 10:30 and 11:30. Um, and um, and yeah, if I have to go beyond 11:30, I can do that, okay? So that is it for this week. Please do your homework, practice, and next week we're gonna be building on this. Okay, so that is it for this week, guys. Okay, take care. Bye.